Welcome to the Good Data Podcast. I'm your host, Drew Farnsworth. Today we have Daniel Pope on the show. Daniel is the CEO of Submer, which is an immersion cooling company for data centers that uses dielectric liquid to actually dip servers into. There are a number of benefits to that, which we'll get into. Primary among those is that the costs of cooling go way down, and also the equipment life can improve because there's no conductive element. Even though air itself isn't conductive, there are particulates in the air. Like if you ever open a cardboard box in a data center, that suddenly creates particulates that can cause problems for future use. This is something I've talked about a lot, that you should never have particulates within the data center. It's not only a problem for electrical equipment, but it's also a problem for fire hazard. So the great thing about these synthetic oils is that they're actually fire retardant to some extent, and they protect the equipment, and you can get 50 kW or more per rack using these immersion cooling techniques. I love this stuff. This is the sort of thing that I have been trying to champion for a while. The industry hasn't quite been ready for it, but I think that's going to change very soon. So I'm very excited to talk to Daniel Pope and discuss Submer. Let's go. Well, Danny, I really appreciate you coming on the interview. I know, it's time out of your day, and I know that you're very busy, so it's nice that you came on. I know that you have a lot of changes that are happening too. That you're coming out with a new product, that you're updating your website, and there's a lot going on. But before we get into all that, I just like to ask how you got into the data center industry. How did you get your start? I know that you were in co-location for a long time, but it seemed like you have a really interesting story of how you got into it.
Yeah, it's one of those garage stories, really.
Those are the best stories.
At a very young age. Yeah, at a very young age, I started with web hosting on a little server that I actually had in my bedroom, and it started off as a hobby, offering email, and this was like really late 90s, so 98, 99. And the thing just went wild. It just took off like crazy. I ended up with 5 or 6 servers in my bedroom. I couldn't sleep in my bedroom anymore. My parents were just going crazy with the electricity bills and the phone bills. And so at one point, they were basically going to throw me out, or I had to take my servers somewhere. And we chose to start with a small-scale data center. We designed very little infrastructure to start off with, but very quickly that also grew and was too small. And then we actually built about a 15,000 square foot data center. It wasn't that big, but it was very dense.
Could I ask you what infrastructure you had in your bedroom? How you made that work? Did you have UPS? Did you have a T1 line? Like, what was the actual backbone of the whole thing?
So the backbone of the whole thing was a DSL line provided by Telefonica back then. So the typical connectivity, it was quite high end, I would say, for the time, because it was already maybe a 256 kbps link. But obviously, other than email, which is a service that you can deliver on a crappy latency and slow connectivity, the websites obviously sucked. By the time we were able to move out of my bedroom into what started to look more like a data center, then we did have multiple T1 suppliers, and very quickly fiber dropped in, and we had gigabit links and so on. So it changed very quickly. And that was up until 2009, where I sold the business to the Telefonica group at a very good moment in time.
Yeah. It's nice when you get right in at the right moment. So with that data center, did you have crack units? Did you have redundant UPS? Did that grow into what you would think of for a normal co-location data center? Or if I guess this wasn't colo,
Absolutely.
this was hosted. This was your hosting data center.
It was managed hosting. We did provide colo as well as let's say a side business, because obviously we had the infrastructure, but it was a tier three, what today would be a tier three data center regarding uptime and redundancy and so on. So we started off with the traditional crack units. Further down the line, we looked for ways, so raised floor, and we looked for ways to optimize with hot aisle and cold aisle enclosures and so on, to make sure that the air wouldn't mix, and kind of you'd see like 5%, maybe 7% increase in efficiency with an implementation like that once you actually closed off the cold aisles from the hot aisles. But that's really all the innovation we've seen in large scale data center, air-cooled data centers in the last 20, 25 years. So other than, and now we start seeing recently like in-row precision cooling and things like that. But up until 3 or 4 or 5 years ago, like the most advanced thing was still to pump air into the floor, which had to come out through these holes in the floor,
Right.
and cool the servers that were at the very top of the roof, very top of the ceiling, right? So kind of, it doesn't feel very smart that you're pumping cold air, which naturally drops anyway into the floor.
Right.
But that's what we were doing.
Yeah, many people are still doing that. So you must have seen that, experienced it, and saw that there was some disruption available. So that parlayed into Submer, which started somewhere around 2 or 3 years ago, right? What was the prototype that you used to start that? What did that actually look like?
The initial prototypes that we worked with were single server prototypes. So we built these in casings where we were pumping fluid through a unique server. And we mainly wanted to see like at what speed we had to pump the fluid, what was the heat capacity of the fluids we were testing, what was the behavior of the IT, the chip temperatures, things like that, the material compatibility. And we could really see that in detail with single server units. So that's what we developed as a prototype at the very beginning. And very quickly that evolved into larger tanks, more fluid, more IT.
I just want to give a preface to immersion cooling. It's something that I've been very interested for many years, but it hasn't really been widely adopted. But the most interesting thing about it is I think that most people imagine if you're dipping computers into a fluid that it's going to short out, that you're going to basically be putting something into corrosive water or some other fluid that's going to have some kind of an electrical issue. But there's a way around that by using a dielectric liquid, right? So what liquid do you use, and how does that work? How does that liquid get right to the chip, and how does it get the heat away from the chip?
Yeah, so the beauty of immersion cooling is that this fluid is actually protecting the equipment from air, from corrosion, from humidity. So although when you see it, you think, damn, that's actually getting wet and it's going to break my IT. It's all the contrary. This is a protective layer. At Submer, we've developed a synthetic fluid. There's different types of immersion cooling fluids out there that you can use with for immersion cooling, and you can use like mineral oil, off-the-shelf mineral oil. You can use vegetable oils, which are dielectric, some of them as well. But the cool thing of synthetic fluids is that you're able to control their chemical composition over time, and you can actually evolve and improve these fluids as a product as well. So for us, it made sense to first develop our own fluid, and secondly, have an aggressive roadmap on evolving that fluid.
Yeah, well, it seems like you're iterating pretty quickly. But just back to the beginning, I'm really interested in the startup world and what it takes to get venture capital, especially in Silicon Valley. So I saw on your website that you actually tried to get into a Y Combinator, the incubator that is in Silicon Valley, which is probably the biggest incubator maybe in the world for tech. I'm not sure, but I saw that they didn't take you on, but they had very good feedback and reasoning for that. And I was wondering if you could just share why they thought that you should go a different route than seeking venture capital right away.
Yeah. So that was 3 years ago. And I'd say the scenario was very different. We were fortunate enough to, out of a bunch of 6,500 startups, we were selected to spend some time with Sam Altman and kind of get his point of view on the technology. Obviously, Y Combinator are really looking at, let's say, unicorn companies that can scale at a very crazy rate. And the B2B scenario that we're in wasn't probably the ideal fit, but they truly love the technology. We at that time positioned it as only having one very advantageous factor, which was efficiency. And today we position our technology very differently. But also the landscape in 3 years has changed dramatically. So 3 years ago, you could, we registered the immersioncooling.com domain. I think that says it all. 3 years ago,
Right.
that domain was available.
That's amazing.
It really does go to show that it was like 3 years ago, this was an unexplored technology and an unexplored market. Today, it's quite easy to see news about new infrastructures being built with immersion cooling, new supercomputers being rolled out with immersion cooling, and OEMs, hardware manufacturers, also fully supporting it. So I think if we were to sit down today with Y Combinator again, we would have a very different response from Sam. And it was also what he expected when we actually spoke with him. He said, "You're still a bit early with this technology, and we have to wait a bit more." That's basically the response that we got from Sam at the end of the day.
Yeah, and if you think about Sam Altman, he's really been a kingmaker and is one of those people who has a great eye for this kind of thing. So to get that vote of confidence, even if it is to say, "Oh, you're not quite ready," that's still a big vote of confidence. So I'm guessing that sometimes a rejection is maybe not just as good as an acceptance, but it's still pretty good.
Well, it didn't stop us on our mission to develop the technology and take it further. And 3 years later, we're on version 4 now of our product, which is going to be released in the next couple of months. And we have our own coolant, and basically we've rolled out to more than 20 distinct customers across the globe. So a very different scenario, yes.
Yeah, so what is the secret sauce? What is special about Submer? There are some other immersion cooling companies out there that have their own methodology, and they've been out for a while and they haven't really cracked the industry completely. So what is different about your technology, and why do you think that your system is going to be adopted by a larger install base?
So first of all, I'd say we in-house, we have data center build and operations expertise, which I think is critical to actually develop a product that's going to disrupt the data center facility and infrastructure down the road. So that would be one advantage. Another would be the agile approach, the liquid approach and methodologies that we apply to physical product R&D and manufacturing. We're iterating very, very quickly on top of our own product. If we discover something that's a problem that's causing an issue to one of our customers, we will completely throw it out the window and build it again from the ground up as many times as we need to. And I think that's absolutely key. Not being completely let's say we are always willing to take a step back and change something that we thought was right, that we thought was going to be the way forward. We are willing to wind back and undo that and make sure that what we are delivering is truly solving the problems and making life easy and practical for the data center to roll out and use immersion cooling.
Right. Yeah, this is a data center product, whereas, it's not a regular computing product. It's not like you're going to put anything less than, let's say, 30 kW in this. So it's really data center focused, which is a good target market now that hyperscale and HPC are getting more widely adopted, I think. So is that kind of your main user base is hyperscale and all the latency dependent and also space dependent applications out there?
Yeah, so let's say that the early adopters or the people that today have the quickest win with immersion cooling are HPC applications, supercomputers, and hyperscalers, mainly because immersion cooling truly makes sense from a density point of view once you surpass the 30 kilowatts per rack. When you're in that range, you just can't cool with air. So that's where liquid comes in. In our case, that's where immersion cooling comes in. And those are the type of customers that are already over 30 kilowatts, and they can take absolute advantage of densities. If you're just focusing on the efficiency of the technology, then whatever you submerge in one of our tanks will operate at a PUE of 1.03 end-to-end, full end-to-end PUE. So that's truly why we think that, and why we see with the customers that we're rolling out, that HPC and hyperscaler are, let's say, the early adopters of immersion cooling.
So you're still somewhat in startup mode. So you're trying to make a use case for industry. And I'm guessing that you don't just want to stop for HPC, that I think that there's a growing taste for having high density in the data center with just regular storage, with regular compute. So how do you make the business case to some of the more regular enterprise customers, the storage, compute, cloud customers? What is the way in to selling that kind of stuff?
The way in is surely to support the hardware manufacturers that they typically work with. That's the way in. So that's not an issue that hyperscalers and supercomputers have, because they either develop their own hardware, or the project is so large that the hardware manufacturer will really get involved and evaluate immersion cooling and support it down the road. When it comes to enterprise servers and, let's say, traditional web hosting and colo facilities, there we need to be able to support a very wide range of hardware manufacturers. As of today, we support quite a few, and that list is growing. But some of the bigger ones like HP, Dell, and IBM are just starting to turn their heads now and starting to evaluate and look at immersion cooling. Once these larger players are onboarded, we are absolutely convinced this is going to be a technology that's mainstream in any data center.
So what does that look like to have support from the hardware manufacturers? You think of something like actually designing the system for immersion cooling, so taking out things like fans, but also supporting the warranties. So what are the ways in which they're supporting your product?
As of today, it's really about them accepting that if you take a server from air-based systems and do some minimum preparation, you're able to submerge it into immersion cooling, and basically they will extend warranties. Down the road, what we are already doing with some of the hardware manufacturers is actually design hardware that is immersion cooling ready, immersion ready. And so the way we see and build a server today will be completely different. You're able to put chips much closer. There's no deflectors for air. There's no fans. The heat sinks are much more, the whole footprint of a server can be compressed. And this is the next step of achieving much denser systems with immersion cooling, for sure.
Right. Yeah. I mean, you take away those big heat sinks, you take away the fans, and also maybe take the power supplies out of the rack itself and move them someplace that wouldn't take up as much space. You can really condense, instead of having a 1.75 inch rack you could condense that and maybe get even more motherboards, more chips within the same footprint, and really get that density up, because you're not worried about air, which has just a higher volume for the each unit of heat that is taken away, right? I'm probably not explaining that as well as I would love, but is that part of the reasoning that densities can increase even more? Is that if you were to redesign the servers, it would improve that ability for heat rejection?
That's absolutely correct, Drew. And there's some hardware standards out there that already optimize drastically your traditional, let's say, 19-inch cabinet and hardware. So you have the Open Compute project and the Open Compute Foundation behind that basically are defining the specification for hyperscaler data centers. And we're seeing adoption in traditional data centers of this standard because it just makes sense. The way that electricity is distributed through bus bars at the rear of the rack, that you have a centralized power supply unit that provides redundant power supply to all the servers in that rack, that you're not doing AC to DC conversion so many times. And these are things that are already out there. And if you apply them to immersion cooling, it already allows us to go way above these 100 kilowatts per single tank that the technology is able to deliver.
Today's episode is brought to you by Green Lane Design. Green Lane has been designing, engineering, and building critical facilities for over 10 years, including major enterprise customers as well as co-location facilities. GLD has designed and developed an integrated stack of design disciplines. If you would be interested in a free assessment, go to greenlanedesign.com, click on Contact, and mention the podcast. So I'm a big fan of the Open Compute standards. I love that there's a data center standard that they've worked out that I have never actually personally seen in the wild, but in a co-location facility, but I know is already in place in places like Facebook and some of the hyperscalers. But can you just explain quickly? I know that you're involved with the Open Compute project, but what is the Open Compute project and how do you interface with it?
So the Open Compute project is an open compute community, as its name says, where a group of hardware manufacturers, customers, experts are sharing specifications, knowledge, designs, and products that are aligned with the Open Compute specification. And this specification is basically designed for hyperscale and high density data centers. So you'll see, as you mentioned, Facebook, Microsoft, they all roll out their data centers with OCP. You have also Baidu and other companies that are doing exactly the same. There's a lot of advantages because you have a specification where you're agnostic regarding the hardware manufacturer. So you can go to multiple, they call them ODMs, so original design manufacturers, where you can take a server specification and say, hey, please build me this, which is a specification that's available online, or the rack specifications. You can take the specification to any rack manufacturer and say, build me this. So it gives you flexibility on the suppliers, on the supply chain, but also the interfaces and usability and how practical the technology is, the specification is regarding day-to-day use. So the way that servers don't have power supplies anymore and that they plug into a bus bar that's at the bottom of a rack to distribute power evenly across all the servers. So much less cabling, stuff like that.
Right. Yeah, there's a number of parts to the Open Compute. There's actually the server design, there's the rack design, there's the data center design, and they're all open standards.
And now there's now the advanced cooling solutions design. Mm-hmm. And that's where in that group, there's liquid cooling. And inside of liquid cooling, we have immersion cooling as one of the technologies that are being evaluated by the Open Compute project to plan for future rollout of immersion cooling in hyperscale data centers, and basically making sure that we're aligning immersion cooling with the specification that it can be easily rolled out down the road and consumed by these large hyperscalers that are already very involved in the standard.
So does that something that you think about from a business case, that part of open compute actually is to make open standards, which then mean that really any hardware manufacturer could take that open standard and produce something with it. So that could commoditize your business in a way that might eat into profits. So, how do you retain that kind of secret sauce and your ability to continue to be a leader in the market despite the fact that it's open?
So we might decide to disclose the designs and the specification of our tanks. Why not?
Mm-hmm.
So that everybody can build immersion cooling racks themselves. What we would do then is obviously provide like smart cooling distribution units that would do the fluid management and have all the monitoring and redundancy built into them. And we would also be able to supply the fluid. So that could be potentially a strategy that we move on with regarding open compute. That surely is something that we're evaluating. But as of today, where we are at a very early stage, it's really about educating and making people aware of the advantages that immersion cooling brings to the data center. And that's the first reason that led us to join the Open Compute project.
Yeah, I am personally a big fan of open standards and not having to necessarily pay for purchasing a standard to build to. It just makes the whole industry able to iterate faster and make better products. And it's something that open hardware has been slower to adopt than open software, but the whole reason that we have had the huge growth in software is because of open standards and things like Linux. It's amazing that hardware manufacturers have tried to hold on to their proprietary information so deadly seriously, as opposed to opening it up and just making sure that the best product out there wins. So I am very happy to see that you're pulling through those standards.
We absolutely believe in open hardware as well. So you'll see us in that space and contributing with specifications down the road for sure.
So how does the actual system work? You have a single box that maybe 23 servers are in that will all have the same essential cooling fluid. So it's one rack that has integrated cooling into it. So how do you maintain redundancy with that rack? How do you make sure that all of the sensors and equipment work properly? How do you actually achieve a tier 4, or I guess maybe you don't want to say all of that, but are you able to achieve a tier 4 Uptime Institute rating with those?
So absolutely yes. Our tanks are designed to have two hulls, like a sailing boat, really. So if we were to have, let's say, an issue with the interior hull, we have sensors in the exterior hull that will detect the fluid where it shouldn't be and will obviously give us a warning. But then the whole pumping system and the power supply to that pumping system has been designed in a way that we have full redundancy, and all the way to we can deploy multiple cooling distribution units inside a tank that allow us to achieve or maintain tier 4 certification for a facility that has a tier 4 certification. So we've built into the CDUs the smart fluid management technology and a substantial number of sensors that are able to detect the fluid environment and properties over time. And basically that's on top of that, we have a monitoring data center infrastructure management integration layer so that we can basically plug in our units into whatever monitoring tools the data center is using. and roll it out as you would roll out a traditional air-cooled rack.
Right. I mean, that is a huge help, is to make this fit within the normal data center framework, right? That you could just plug one of these boxes into a co-location data center, so long as they have a chilled water loop that you could pull off of, correct?
Yeah, and most facilities already have chilled water. When we're connecting into chilled water, it's quite surprising the amount of dissipation that we can achieve. So one of these 22U tanks that you mentioned, the 23U, we also developed a 45U version, but we've been able to dissipate with chilled water over 150 kilowatts of heat from a 22U tank.
Wow.
So as of today, there's no IT equipment for that. So we've done it with industrial heaters to prove that we're able to do it. And obviously, theoretical calculations, it's all physics, allow you to estimate how much you'll be able to dissipate. But the magic of immersion cooling is doing that with ambient air temperatures. So not with chilled water, doing it with warm water loops.
Mm-hmm.
And we're able to do that as well. We typically install our tanks and connect them to dry coolers or adiabatic cooling towers. But systems that don't have chillers, that don't have compressors, that consume very little energy, they're just acting as large radiators on the outside of the building. And that's what allows us to achieve this unrivaled PUE of 1.03 for a full installation.
Yeah, I was just about to ask you about that. So you would just have the heat exchangers in the rack that would connect to a warm water loop, or possibly two warm water loops for redundancy, and then the water or glycol would just go out to a dry cooler or a cooling tower outside. So that way you're taking out the whole very expensive, very energy intensive process of phase exchange, right? With actually compressing liquid to reject heat. So I have a question. Has anybody approached you about reclaiming some of that heat to heat a building or something like that? Is that something that people have approached you about, or is that, I'm sure that's not really something that people care too much about, but it is a way to use that rejected heat to do something useful.
So it's obviously extremely easy to use this to recover this heat and use it to warm up your office space in the data center. That's the easiest approach, but we're seeing already some of our customers going way further than that, and they're basically positioning their data centers a power generation plant, a heat generation plant,
right,
that's able to provide heat to the buildings in the vicinity, or to warm up a local swimming pool, where we have already an example in the UK. So everybody's thinking about that, and I'm hoping that down the road we see more and more applications where this heat that we would typically just throw into a river, a lake, or let go into the ambient air is being used multiple times before we actually do that, right?
Right. Well, it's. I had a funny example of that. There was a crypto mining facility that was talking about reclaiming some of that heat and using it to heat up a marijuana grow facility. But I think it would be a regulatory minefield. It's like, oh, you want the feds knocking on your door 5 times a day? You put the crypto with the marijuana, and then you have even more trouble. But in a way, it almost makes perfect sense, because then you have great security for both. And
yeah, even for more traditional, let's say hydroponics, or let's say farming, green farming, and so on, you can reuse this heat as well. So there's a lot of applications. I think a lot of people will be able to come up with ideas on how to reuse the heat that these data centers are generating.
So
once you have it in water, it's easy to transport and easy to reuse.
Right. So, one of the nice things too is that you can take these boxes and put them in hot environments or at the edge, so that, this 50 kW box could take over what would have been a very small data center 5 years ago, you could take that entire small data center, put it in one of these racks, and place it in a place that is in a harsh environment, and it would still be protected. So is that also part of the use case? Is hot environments, protected environments, hostile environments?
Absolutely. We're now able, so it's the future, we see it all about edge. That's going to be one of the major trends. We're going to have to roll out data centers in regions where no one would have thought of before. We've obviously naturally rolled them out into cold regions. Here in Europe, we have most of the data center capacity in the Nordics. And that's obviously for cheap electricity and the let's say, capability or the possibility of being able to use free air cooling. But immersion cooling allows us to still have that PUE of 1.03 in the middle of the desert. And so we are already rolling out our technology in the United Arab Emirates, for example, in Israel, in Hong Kong, in Vietnam, in countries where humidity and heat have typically pushed infrastructures to have a PUE of way above 2.5. So we're going to see more and more of that with edge, of course.
Yeah, the good thing about that is that those are the emerging markets, so you can kind of start from scratch. I think that's a really good opportunity to really grow out those markets, maybe for less cost, less capital input than would normally be required. So it's a really good
Absolutely.
thing. And I saw, because I'm a big physics nerd, I'm not smart enough to really understand all of particle physics and quantum physics, but I saw that you have a install at CERN. So did you get to go to CERN and see it and see that installed?
Yes, we're lucky enough to have now just an evaluation unit at CERN, which is in the LHCb experiment, one of the main experiments. CERN has a very interesting use case for immersion cooling, and that is they've built this massive accelerator, which is buried 200 meters underground. And the space they have for compute is extremely small down by the accelerator, but the amount of data they collect is so huge that they need to have the compute close to the accelerator to pre-process most of that data, and they're basically throwing away 95% of the data that the sensors capture. They have these algorithms to just, let's say, kind of figure out which of that data is important and just capture that 5%. But that 5% already represents billions of terabytes and petabytes of data per second. And basically, immersion cooling is allowing them to multiply by 10 the compute capacity that they can have in this confined space of the accelerator.
Did you get to get a tour, or were you just limited to seeing the LHCb, the Large Hadron Collider, which I forget what the B stands for, but was it the Beauty? Was that looking at the Beauty quark?
That's the Beauty. Yeah. That's the Beauty. Yeah. So we obviously got the tour. We're lucky enough to have some very good support at the CERN facility for it's not easy to get technology into CERN. I have to say it's the requirements and the security requirements to deploy a technology at CERN are pretty extreme, but it solves such a big issue for them that they've made it easy for us. And we've had the VIP tour of the facility multiple times, luckily, and my engineers as well. So it's we're hoping that over the next 18 months, because now the accelerator is actually shut down for maintenance during 2 years. And what they do during those 2 years is upgrade. They spend billions of euros in upgrading the sensors, upgrading the infrastructure, evaluating new technologies that will then be taken into the accelerator. And hopefully immersion cooling is going to be one of them. That's what we're there for.
I'm guessing that they have some pretty amazing, this is a diversion, but some pretty amazing heat rejection, given that they have such a huge liquid nitrogen framework about the whole thing, that they could probably get rid of that heat somehow within the facility. Maybe you can't talk about that, but it's just very interesting environment to do work in.
It absolutely is. It's like working in a nuclear power plant, really.
Right.
It is fed by multiple nuclear power plants. When it's running, it consumes, I think, 120 gigawatts or something like that. And the cooling towers that are there in the vicinity are just absolutely impressive. Um, the thing is, the density, I said, once you go over 30 kilowatts per rack, it doesn't matter how quickly you push air into that rack, you cannot cool the servers quick enough. So they're looking for higher densities. It has to be one shape or form of liquid cooling, could be direct to the chip, could be immersion, and we're happy there to support CERN with immersion cooling.
So at you got your start in data centers, which is great because that means that you understand the data center business, but now you're in manufacturing as well. So how have you made that pivot and what did you learn from data centers that really helped you to make the transition to being in the manufacturing sector?
Good question. Very good question, Drew. I personally see data centers already as a large machine with lots of suppliers, lots of components, lots of hardware, right? Our company at the end of the day, so manufacturing a product at the end of the day and delivering a hardware technology is really the same. It's working with a lot of vendors, a lot of suppliers, a lot of hardware components that you need to put together and get them to work as a single machine. So I see a lot of similarities in what running a large data center or running a hardware startup is. And I didn't expect that at the beginning, but there's a lot of synergies there, and it's been surprising.
And I saw that you have your offices in Barcelona. And I think I saw on LinkedIn that you have some language endorsements that you speak the Catalan and the Spanish and the English. So is that why did you choose Barcelona, and is that where you feel most comfortable and doing the actual manufacturing in the box?
Yeah, but Barcelona is my hometown. It feels like home for me. Although I grew up in the UK at the age of 10, my mother basically said to my dad, my mother is from Barcelona, my dad's British, and she said to him, look, why are we here? Like food, weather is kind of substantially better in Barcelona. Could we please go to Barcelona once and for all? And my dad said yes, of course. So since the age of 10, I've been living in Barcelona, and it just already feels like home. I'm native, as you said, Spanish, Catalan, and Castilian speaker. And the cool thing of Barcelona for us as a startup is there is already a very, very strong startup movement in Barcelona. But here we're able to find the most incredible engineers, very, very smart people with very reasonable salaries. So it just makes sense. I mean, you cannot compare it to something like the Bay Area, where you probably would be paying 10 times more for someone who has very similar qualifications. And Barcelona also provides us with incredible infrastructures to provide our technology worldwide, like the Port of Barcelona, which is on the main lines of most of the large shipping lines, and the airport of Barcelona, which is a reference also in Europe. Apart from that, Barcelona has been very well known for its network of manufacturing expertise in practically any type of machinery. We produce cars here. We've since the Industrial Revolution, Barcelona has been a very large manufacturing city. So we're based in just the outskirts of the city, where there's very easy access to the port, as I mentioned, and it allows us to have access to all this knowledge, these suppliers, and it just makes it comfortable for us.
Yeah, I am very envious right now because I look out my window and it's the grayest day and it's probably 30 degrees outside here in Philadelphia. So it must be nice.
Today it's nice and sunny nearly like every day of the year.
Right. Yeah, I had a friend who vacationed in Barcelona a little while ago, and I saw the pictures. And that same year, I was vacationing part of the time in Italy, but I had also spent a good amount of time in England. And was there a difference between our pictures, even in the summertime?
Yes.
So
Yeah.
I understand that you are currently ramping up production. Have you felt like you've reached a scale where you can really put out a large deployment with your current manufacturing?
We've designed our manufacturing chain to be, first of all, very lean, but also very replicable. So the way we're assembling our units and doing the QA, and the way we work with suppliers and sourcing, like dual sourcing of those suppliers, etc., allows us to easily take our current production model to any region. As of today, we have it here in Barcelona, as we've just mentioned, and with a very small space, we're able to produce 5 units a day. Let's say our mission for 2018 was to produce around 50 units. Our mission for 2019, our vision was to produce just over 200 units, but we think we're gonna multiply that number by a few. So probably what we'll do is just expand our production plan as larger orders come in. But as of today, we're ready to take in orders in the hundreds for sure.
Great. And just going back to the business case, it seems as though I've talked to a number of people about this, but there is more of a hunger for green technology in the European Union, the UK, versus the American. Is that your estimation as well? And is that a different positioning in the two continents?
Yeah, so that is true. Unfortunately, Drew, we do see that our European prospects and customers are more concerned about the efficiency than our US prospects and customers. I think that's also because the European Commission, as such, is putting a lot of effort in policies that will reduce carbon emissions and enforce greener infrastructures. Actually, our technology was accelerated thanks to a grant from the European Commission a year ago in one of their lines of work, which is reducing carbon emissions and their aggressive roadmap over the next 20, 30 years. So there's been money put into companies that are bringing technologies that can disrupt the current efficiency of a traditional industry. I'm not sure if in the US there are similar policies, but we do see that difference in mindset. The type of questions that we get from our European customers, a lot of them are around the efficiency.
Right. Yeah, the US just has a very different framework for that kind of stuff. We have the Energy Star program and certain incentives, but we really don't have the same type of regulatory framework that would penalize people for having deployments that are not as green as they could be, it's interesting because I've talked about this a lot, but data centers take up, I've seen estimates between 3 and 6% of global power, and that really bumped up a lot with the Bitcoin and this cryptocurrency usage. So to me, any reduction in that is good for just about everybody but the energy companies. And I would think that people would care more about their bottom line in terms of efficiency. But for some reason, there have been a lot of business cases that I've seen that companies don't seem to care in the US. So maybe that'll change. I don't know.
It's practically 4% of the global CO2 emissions what data centers are generating. So it's a number to really think about. I'm quite proud that the European Commission is even considering, and it's been discussed a lot, and it seems like it's going forward. But there will be energy taxes for data centers in Europe that are operating over a PUE of 2.0. And I have to say, I feel very proud about that. It's also very good business for us, hopefully down the road. But I think it's the only way that people are going to consider making their infrastructures more efficient, especially like older infrastructures and so on.
Well, I think that's just about everything I had, but is there anything else that you wanted to talk about in terms of your design, where you're going, anything that I missed?
Well, we're releasing in March version 4 of our product, which is going to be available in a 19-inch and a 21-inch OCP format. And that's going to be both in 22 U's and 45 U's. And the cool thing about the technology that we'll be releasing in March is it's completely different to what we have today on the market, but we truly think it's going to be a leap forward in how practical immersion cooling is going to be for the data center. I can't unveil much more now because we are just completing our patent registration and IP around the new product, but please be on standby. You can reach us over our socials, our website, and the upcoming events that we're attending. In the US, most specifically, you'll be able to see us at the Open Compute Summit in San Jose mid-March. That's 14th and 15th of March, and at Data Center Dynamics in New York in April. And we always attend also supercomputing event, which is going to be in Denver this year in November. So looking forward to meeting your listeners there.
So you mentioned your social, and I'd like to say that I've appreciated the content that you put on your website and what you put out there, because one of the things that you put out was a primer on how to basically get a server ready to put in an immersion cooling environment, which I hadn't seen before specifically, and it was nice. It was very short and just quickly noted how to take fans out and replace them with fan emulators. And can you just quickly explain how easy it is to get a server ready for this type of deployment?
Yeah, well, it's a process that we've really looked at simplifying because we think it's the first step to take immersion cooling mainstream, is to be able to just take any off-the-shelf server and dunk it into your tank. And to do that, you basically need to do a couple of things. One is remove the thermal paste from the CPUs or GPUs and replace that thermal paste with indium foil, which is, let's say, a highly heat transfer foil that you just cut into the shape of the chip and place exactly in the same place where you had your thermal paste. You have to disable all the fans. Now, there's some servers that will allow you to do that easily, but there's some that won't, especially the power supply fans. It's usually a pain. For that, we've developed these micro fan emulators that we provide to our customers. So you just unplug the Molex connector of the fan, plug in this little emulator, and it's depending on if it's a 2, 3, or 4 cable fan, it's going to emulate the frequency that the fan had. The server won't even know that you've actually unplugged the fan and plugged in the emulator. And other than that, you have the SSD drives. You have to make sure you have solid state drives or helium sealed drives because the traditional drives won't work, and you're able to put that server into immersion cooling.
Yeah, thankfully a lot of that change to solid state drives is well on its way, so the timing is good on that as well.
Yeah, absolutely.
So, yeah, you mentioned your socials, but can you just tell us how people can contact you, how they can find you, Twitter, Facebook, or whatever you put out there?
Yeah, absolutely. You can find me easily on LinkedIn, looking at my name, or daniel@submer.com. Please don't hesitate to reach out if you have questions on the technology, or want to run a proof of concept, or want to see one of our customer installations. We're really focused on education right now, so any question is absolutely welcome for sure.
So I think I mentioned to you previously that I had put together a Raspberry Pi, one of the chewing gum sized computers, and put it in an immersion, in a mineral oil just for my own belief that it would work. And I dug that out recently and plugged it back in, and it still works. It's still an effective thing. It's a fun little gadget to have to actually see it firsthand that the immersion style works. So that was part of the reason that I bought into it, was I actually saw it in person.
You can do that experiment very easily by just purchasing off-the-shelf mineral oil and running a test like that. I mean, in the long run, with mineral oil, you'll encounter some issues like the cables hardening and capillarity, and maybe even some materials that you'll see having some issues with the oil. And that's one of the reasons it's a good way to test the technology and to see that actually you can get a piece of a PCB board or something working inside a liquid without any troubles. In the long run, as I said, you will run into issues, and that's where you want to use like a fluid that's specifically crafted for immersion cooling, and that's basically what we're delivering with our technology as well.
Yeah, that's exactly what happened to me. The cables kind of hardened and almost dissolved. It was not a good situation, but it still works. That I could replace those cables and it still works fine. So it's very interesting. Well, I think that's all I've got. I really appreciate you talking to me, and I see good things in your future. So thank you for coming on.
Thank you very much for the opportunity, Drew, and hopefully we'll be able to repeat this session down the road and update you on where we're taking our technology and where we see immersion cooling.
Yeah, that would be great.
Thank you.
Talk to you soon. Thanks. That's our show. I'd like to thank our guest, Daniel Pope, and our sponsor this week, Green Lane Design. Tune in for continued coverage of our Green series. We have some more fantastic interviews coming up. I can't wait to share some of our guests with you. And I am just very thankful for the great reception that this podcast has already had. We'll talk to you next time on the podcast.